Management Chapter 6. We're going to be looking at managing natural hazards. And the first thing your syllabus expects you to know is the earth structure. What are the various layers of the earth? The earth is made up of the core, which is divided into inner and outer core. Then you have the mantle. Then you also have the crust. The inner core, it's a solid layer. It has a temperature of approximately 5,500 degrees Celsius, and it contains two major elements called iron and nickel. While the outer core is a liquid layer, and that's the major difference between the two. The outer is liquid, while the inner is solid. Now, the mantle is the widest layer of the earth, approximately 2,900 kilometers. And the mantle is made up of semi-molten rocks called magma. And in the upper part of the mantle, the rock is hard, while in the lower part of the mantle, it is quite soft. Now, the crust is just approximately 0.60 kilometers thick, and it is made up of two parts, which is the continental crust, which carries the land, and the oceanic crust, which carries water. Now, the oceanic crust is younger, it is heavier, it has a higher density of 3.0 gram, it can sink and is constantly being destroyed and replaced. While the continental crust is older, it is lighter, it cannot sink, and it's permanent. So the next thing your syllabus expects you to know is plate movement. So there are three major types of plate movement, which include the constructive plates. So plates, boundaries, are where two or more plates meet. So we have the constructive or divergent plate boundary. Now, in a divergent plate boundary, two plates move away from each other. When two oceanic plates move away from each other, it creates a space for the magma to erupt and rise to the surface through a process called convection current and solidify. When it comes in contact with cold ocean water, now the magma turns to lava and form new basaltic ocean cores. So, in the case of constructive plate boundary, as you can see, the two plates are moving away from each other, which now creates space for magma to erupt to the surface. Once magma leaves the mantle to the surface, it's now called a lava, and it solidifies to form a volcano. And this volcano in this type of constructive plate boundary are usually basic, and it forms a shield, and it is actually non-explosive. That means it does not cause high amount of destruction. And when it happens between oceanic plates, it normally leads to what is known as seafloor spreading. Now, if two continental plates move away from each other, a reef valley may be formed in the process. Then the second type of plate boundary we're looking at is destructive plate boundary. Now, in destructive plate boundary, you have two plates move towards each other. So the oceanic plate and the continental plate are moving towards each other. And because the oceanic plate is denser, it is more heavy, it is forced to move under the continental plate, forming an area known as the subduction zone here. Now, so it's subducted under the lighter continental plate. This happens in the subduction zone, and the oceanic trench is formed. The friction between the plates as a result of the collision can trigger an earthquake, and the heat produced due to the friction turns the descending magma, the descending, plate into magma. So it will melt the oceanic plate and convert it to magma, and the magma starts to rise and erupt due to pressure through a weakness in the crust as an explosive composite volcano. So this can lead to composite cone volcanoes. Now, fold mountains are also formed due to the collision here between the two plates. Now, the magma that erupts at the surface form a chain of volcanic island called an island arc. Now, if two continental plates move towards each other, the sediment between the two plates are compressed. Now, because they are both continental plates, none is going to be subducted because none is heavier than the other. So what you have at such zone is called collision zone, and you have a series of fold mountains. Now, earthquake occur, but no volcanic activity, as there is no subduction of oceanic plates in the case of two continental plates moving towards each other. But in the case of destructive boundaries, you find out that you have continental and oceanic plate moving towards each other for this criteria for this to actually happen. Then lastly, we look at conservative plate boundary, where you have two plates slide past each other. Two plates slide past each other, they move in different speed, and the plate gets locked together and pressure build up, and once the pressure is released, an earthquake is formed. Now, so we'll look at volcanoes now, which is one of the first natural hazard. Now, a volcano is essentially an opening in the earth crust through which magma from within the mantle is erupted onto the land. And what are the causes of volcano? It is formed at constructive and destructive margins. Now, at constructive margins, plates move away from each other, creating a space or a gap on the earth. Magma from the mantle rises to fill the gap. While in destructive plates, oceanic and continental crust move towards each other. The oceanic crust is heavier, so it's subducted or move under the continental crust into the mantle. The oceanic plates melt from friction and heat from the mantle, so the newly formed magma is lighter, so it erupts to the surface. And these normally lead to shield volcano, while this lead to composite cone volcano. I don't think if you're doing geography, then you are expected to know the difference between the two, but in environmental management, you are just looking at it as a hazard within the environment, so you don't need to know the types. Now, earthquake. An earthquake is the shaking and vibration of the earth crust due to movement of the earth plates. So it's shaking and vibration of the earth crust majorly due to movement of the earth plates, which are known as plate tectonics. Now, earthquake can happen along any type of plate boundary, but the major causes is at destructive and conservative plate boundary. Now, earthquake occur at conservative plate boundary where two plates slide past each other. So the friction between the plates lead to the buildup of pressure. Now, once the pressure is released as plates move suddenly, this sends shock wave through the crust from the focus, leading to an earthquake. Now, what is the distribution of volcanoes and earthquake? Simple. Whereas earthquake occur at volcanoes formed is governed by plate tectonics. Plate movement is caused by tectonic movement in the earth crust. Plate movement is caused by tectonic movement in the earth crust. So when you have earthquake in terms of distribution, it encircles the whole of the Pacific Ocean, and it extends down in the entire length of the mid-Atlantic region, and it stretches across southern Europe and Asia. While volcano also encircle the whole part of the Pacific, usually around the Pacific Ring of Fire. The same thing, it extends down the entire length of the mid-Atlantic Ocean, and some in southern Europe, the Caribbean, and East Africa. Now, in exam, what will be given to you, they can give you a map like this, and you have to use it to describe which type of plate boundaries exist in there. Now, you can understand that in this part, the two plates are moving away from each other, so a constructive plate boundary is there. Here too, between Eurasian and American plates, you have a constructive plate boundary here. Now, if you look at this, you find out that around this path, you have a destructive plate boundary here. A destructive because they are moving towards each other. Now, Philippine plate and the Indian plate, you have Pacific plate and the Indian plate moving towards each other. Here you have a destructive plate boundary. Then if you see a plate where they slide past each other like this, then you have a conservative plate boundary here, so you can have high amount of earthquake activity taking place there. Now, understand the magnitude and the Richter scale. Now, the power of an earthquake is measured using what is known as a seismometer. A seismometer detects the vibration caused by an earthquake. It plots this vibration on a seismograph. So the strength or magnitude of an earthquake is measured using a Richter scale. Now, the Richter scale is numbered from 0 to 10. So looking at the magnitude of an earthquake from 0 to 2 to down 8 up, you'll find out that the effect of the earthquake differs. Now, at 0 to 2 is usually not felt by people, 2 to 3 felt little by people, 3 to 4 ceiling light begins to swing, 4 to 5, wall will crack. 5 to 6, furnitures move. 6 to 7, some buildings will collapse. And 7 to 8, many buildings destroyed, and total destruction of buildings, bridges, and road if the magnitude of the earthquake is from 8 and above. So we're done with earthquake and volcano. So let's see tropical cyclone. What is the causes of tropical cyclone? Now, anytime you hear things like a storm, hurricanes, typhoons, they are all examples of tropical cyclone. So the causes of tropical cyclone is simple. It is formed when the ocean surface temperature is at least 27 degrees Celsius. Ocean surface temperature is 27 degrees Celsius. So warm water provides the energy to evaporate more water. Now that rises, condenses, releasing huge amount of energy. Now the ocean depth of at least 60 meters deep, and this condition is occurring between 5 degrees and 20 degrees north and south, which have a sufficient Coriolis effect, making the air within that region to spin. So it has very little wind shear, so it changes in wind speed or direction is quite very little changes. So these are the major reasons. You must have a surface temperature of approximately 27 degrees Celsius, and the ocean depth should be at least 60 meters deep, and because of high temperature, more water will rises, and once it rises, it releases energy, and actually a huge amount of energy, and it occurs between 5 degrees and 20 degrees north and south of the equator, which have sufficient Coriolis effect to make the air within that region to spin. Now, what is the distribution of tropical cyclones? You find that we've stated it earlier, it is between 5 to 20 degrees north and south of the equator. So if this is the equator, you find out that just 5 to 20 degrees north and south within this region, you can easily have a tropical cyclone. They do not form on the equator because the Coriolis effect there is 0 degrees. Now, the air at the equator tend to flow straight from high pressure to low pressure without any form of rotation. So if you need to understand this, you can watch my video on weather, climate, and ecosystem in IGCSE geography. You understand how pressure belt works. Now, flooding is another natural hazard. So there are physical and human causes of flooding. So in terms of physical causes, we have heavy rainfall, prolonged rainfall. So heavy rainfall reduces the infiltration capacity of the soil, and it increases in overland flow. If you want to know the meaning of infiltration capacity, you watch the video on water and its environment, chapter 4. Prolonged rainfall saturates the soil, causes the water table to rise, reducing infiltration capacity. When you have snow melt, land relief, so the steeper the gradient, the higher the overland flow, therefore it can lead to higher rate of flooding. Saturated soil. The more saturated the soil is before the rainfall, so lesser infiltration and more overland flow. Where you have things like storm surges and tsunamis, flooding of low-lying coastal areas. Then human causes of flooding include deforestation. It reduces interception and infiltration. Cultivation of land, so plowing down rather than across slope increases water flow. Urbanization, so concrete and tarmac are impermeable surface, so no infiltration takes place. It does not allow water to pass through it, therefore lead to high overland flow. Climate change, so things like global warming may lead to rise in sea level and more rainfall in some areas. Then next, look at drought. A drought is a long period when rainfall is below average for an area. And what are the major causes? Causes of drought is majorly lack of rain caused by prolonged high pressure. Lack of rain caused by prolonged high pressure. Now, drought is an extended period of unusual dry weather where there is not enough rain. Now, the lack of precipitation can cause a variety of problems for local communities, including damage to crops and a shortage of drinking water. Now, second impact, causes of drought. Another cause of drought is the El Nino, southern oscillation, and the La Nina effect. Now, I think we've explained this a little when we look at El Nino Southern Oscillation and its effect on ocean and fisheries. But bringing it here, in a normal condition between South America and Australia, you find out that normally the trade winds blow westward. So in a normal condition, trade winds here blow westward. So the warm equatorial trade wind blow westward, and it carries along with it um, it's a warm current, so which rises at Australia, uh, condenses and fall as rain. Then during this normal period, you find out that the west coast of South America tend to experience a very dry weather, and as a result, a high amount of drought possibility within the western coast of South America. So let me just read through quickly. This low pressure over Australia with air rising and cooling, so the water vapor condenses to form cloud. This brings precipitation to the western Pacific, and there is high pressure over the eastern Pacific, so air is sinking and warming up. So this means no condensation or precipitation occurring there. So you find out that the trade wind is moving from this to this, so it's moving westward from the east coast. So once it gets here, because it's made up of warm equatorial current, it rises and condenses to form cloud, and as a result of a high amount of rainfall in Australia, while this area here is made up of cold current, and as a result there will be high possibility of drought within this point because there will be rainfall in this eastern Pacific. Now, but in an El Nino condition, that is in a normal condition, in an El Nino condition, the air flows eastward instead of westward. And as it flows eastward, you expect that the warm current will now rises around South America in El Nino condition. It rises, condenses, and fall as rain. So there will be high amount of torrential rainfall here. While in Australia and the west coast of the Pacific, they will be experiencing drought during El Nino condition. So that's it. It's that straightforward. Now, but we have something called La Nina. La Nina is when normal conditions become more extreme. When you have an extreme normal condition, what you now have is known as what? A La Nina. But in El Nino is when the opposite of the normal condition happens. But in La Nina is when you have an extreme case of the normal condition, where trade winds blow more strongly towards the west, causing more warm water to build up near Australia. Now, this causes heavy rainfall and eventual flood during La Nina. In this area, in the eastern Pacific / South America, there is less rainfall than normal, which can lead to drought. So, what it means is, we are looking at drought and causes. So, in La Nina condition, there is extreme. It is an extreme of the normal condition. So if this is normal condition, when there's extreme of it, that means the amount of equatorial trade wind or warm air is high, which will now lead to excess and excessive rainfall and leading to flooding here, while this part we still experience drought. So climate change is also another cause of drought. So while drought can have different causes depending on the area of the world and other natural factors, the majority of scientists have started to link more intense drought to climate change. Now, that's because as more greenhouse gases emissions are released into the air, causing air temperature to rise due to global warming, more moisture evaporates from land and lakes and rivers and other bodies of water. So warmer temperature also increases evaporation in plant soil, which affect plant life and can reduce rainfall even more, therefore leading to impact of drought or excessive drought. Now, what is the impact of natural hazards? You see, when you hear hazard, all hazards have similar impact, just few variation occur between them. So you find out that tectonic hazards have to do with earthquake and volcano, has to do with damage to buildings and infrastructure, fire outbreak, tsunami, can lead to landslide, and loss of farmland and habitats, water-related diseases such as cholera, it can lead to loss of life, it can lead to trauma, it can lead to financial losses. While flooding can also lead to loss of life, loss of livestock, loss of crops, damage to buildings and infrastructure, contamination of water, water-related disease, and financial loss. You see, their both impacts are similar. So if you just remember one, you should be able to answer the impact for all of them. While in the case of tropical cyclone can lead to flooding, lead to loss of life, lead to financial losses, damage to buildings and infrastructure, loss of crops and habitats, water-related diseases. Then things like droughts can lead to death of organisms, water sources dry up, decline in crop yield, starvation, increase in soil erosion, desertification. We have things like decrease in air quality and increased risk of wildlife. So how do you manage the impact of these natural hazards? Managing the impact of natural hazard, if you look at all the 4 natural hazards we've looked at so far, all have what? Monitoring and warning, monitoring and warning, monitoring and warning are all one method to manage the impact of hazards. Now, but in the case of volcanoes and earthquakes, you can have land use zoning, or so you don't build on areas that are prone to volcanoes. You now have things like structures where you have earthquake-proof buildings and disaster preparation like earthquake and volcanic drills. You have emergency rescue teams, then evacuation of the area, rebuilding of damaged areas, international aid and food storage, all method of managing tectonic hazards. Then managing flooding, outside monitoring and warning, you can use your storm hydrograph to predict when flood is likely to occur. You monitor the runoff, you build good shelters that is difficult to be washed away by flood, and rescue team, and rebuilding of damaged areas. Flood management techniques should also be put in place. You can also increase the levees. Now we have managing tropical hazards, structural building. Also we have disaster preparation, just like this, they are similar. Evacuation and emergency shelter, rebuilding of damaged areas and international aid. By managing drought, you have emergency water supply, water conservation, increased water supply, and international aid will all help to manage drought. And increased water supply, such as creation of dams, reservoirs, water storage wells, use of aquifers, water transfer, desalination, and rainwater harvesting are the various methods used to increase water supply. Now, what are some of the opportunities presented by hazard? Opportunities presented by natural hazard. We have importance of flooding, such as deposition of silt, alluvium, which is good for agriculture. Then in the case of importance of volcano, tourist attraction, provide income and employment, create fertile soil, and the lava and ash add nutrients to the soil, which lead to increased high agricultural production. Heat generated provide good source for geothermal energy. Most volcanic rocks are source of rivers. They provide gravel for buildings and contain minerals which, when excavated, provide income for farmers. Now, we've covered everything that has to do with this topic. So it's for you to listen, get your pen, write down the major notes and summarize it.